and the other members of the team will introduce themselves. We're going to spend about 25 minutes talking about some of our services. We're going to go through it kind of quickly, just sort of give some overview of some of the services that we offer. Then we're going to have a facilitated question and answer session. Actually, we're going to ask you some questions, and you're going to see these questions in a minute. And we're going to post them in the chat, so you don't have to wait until that part of the workshop to post your answers to the questions or post any other questions. So feel free throughout this whole hour and a half that we have to put questions, comments, and answers to our questions into the chat. Then after we've had the facilitated question and answer, we'll be at about 2 o'clock, and we've organized some breakout rooms along like the lines of our different services, and that's a place where you could go and get sort of a deep dive, ask some questions, and get some expert help on that. Okay, so I introduced myself. I'm the director of the Research Cyberinfrastructure Group. Tobin Magley, excuse me, is our training and outreach lead. Tobin actually organized this session, but had to step away this week. So she left behind a great presentation that the rest of us are going to be leading here. And next on the team is Chris Layland.
Hi, I'm Chris. I'm our RCI cloud engineer, which cloud in this context is going to be Amazon Web Services, Microsoft Azure, and Google Cloud. So not as much software as a service or software that's running in the cloud. And I get to help researchers figure those things out and leverage them.
Michael.
Hi, I'm Michael Layde. I'm the Research Cyberinfrastructure Storage Lead. I've been a longtime DoIT employee and have gotten to work in the infrastructure and storage space, and now lucky enough to get to focus exclusively on research and working with a lot of groups.
Thank you. Sam.
Hi, I'm Sam. I'm the student help here, more or less an intern. I'm pretty involved in a lot of the different projects kind of at a higher level, looking at metrics and yeah, figuring out how we can help researchers.
Great, thank you. Erwin.
Hi, I'm Erwin, and I am the graduate project assistant. And I have this great opportunity to work with all of them. And I'm a junior researcher myself, so I get to play with several pieces and try to bring them together. It's a lot of fun.
Thank you, everyone. Okay, so these are the promised questions that we'd like to ask you. And again, feel free to post answers or questions about them in the chat throughout. We'll sort of get to these questions after we go through kind of a quick round robin on our services. But we're curious about your research workflow, and this is really how you can help our group grow, is by sharing it with us, sort of what's going well in your research workflow, what's the hardest part, what tools might you be missing? Are there times when you think you're spending lots of time doing something and think, wow, isn't there an app that could do this instead? That would be good to know. And we'll sort of take all of that and any direct suggestions you have as some possible ways that we could help and our services could grow and expand.
All right, thanks, Jen. And we're talking about a workflow or a life cycle. This is sort of the model that we have in mind in terms of different phases and different steps involved in a research process. And certainly there's the unique aspects of each individual one, but some of these common areas or themes. And we're going to kind of talk through the different parts of this life cycle and address some of the services that we have and how they can fit in and try to describe some of this in context. All right. If you wouldn't mind advancing, Jan. Yeah. All right, this is one of my favorite slides because it keeps growing with more options and and more stuff to offer. So these are some of the landscape of what the DoIT and the Research Cyber Infrastructure team have, with some of the different service offerings oriented around the data life cycle, and it gives you a little hint of where some of the things fit in. But a lot of these things will have fit across different phases, or could be used in conjunction. So we're going to kind of talk through some of the different parts, the planning and that part, that's very specific to the researcher and the grant and the project. We're happy to talk how we can fit into that, but then where a lot of the service offerings and things fit in as well. So if you wouldn't mind advancing, Jen.
So this might be my slide. I think it is.
Yeah.
So we mentioned we offer some services. We're going to talk about those in some detail next. We also consult with different research groups on campus. So if there's a way we could help you, if you sort of want to rethink some of your data management or computing workflows and how those interact with data, that's something we can do. We also do outreach, so trainings and workshops, and we collaborate quite a lot with other campus groups, including the Data Science Hub, the libraries. We're always interested in any feedback we hear from researchers, and just sort of do some communications with the research community as a whole. Mike, this is you again.
Yeah, thank you. So, data and storage is one of our big areas, and there's, a lot of services or different options in this space. But, at the high level, some of the, important themes are, with data growing in a lot of different fields, making sure that there's, enough capacity to be able to store and keep up with data, making sure that it's protected and multiple copies to, protect against accidental deletions or security concern, those kind of things, and who you're collaborating with, where you need to work with your data. There's a lot of considerations that are out there. So we're going to walk through some services next and just talk through some of the options that are available to folks on campus and talk how they can fit in a little bit. So you wouldn't mind advancing, Jen? Thanks. Mm-hmm. All right, so Research Drive is one that I'll start with. I'm the service lead for Research Drive. It's a campus-wide file storage service that it's pretty new. It's from the last couple of years, and when it was one of the new offerings that was made available to all researchers and designed to not solve all problems, but to give everybody, all PIs in their research group, a decent baseline of storage that can be used for different purposes. So this is network detached storage that's really geared around the campus network. So it's easy to access from different in different departments or workstations, laptops. You can connect in with a VPN, but it's really oriented towards the the campus community, and easy to collaborate with. But you can also share with external people, and there's a few options on that. But a lot of it's geared for primary working storage for a research lab or a research group. All right, and we, as opposed to this sort of file storage, we can cover in some other options. Would you mind advancing, Jan?
Okay, this is me, I think. So one of the services we offer is an electronic lab notebook service. It's a product called Lab Archives. It's a digital analog of the traditional paper lab notebooks. It's helpful, though, if your data are all digital, to be able to create digital notes about the research process alongside the digital data files. It's also a great tool for collaboration. So lab groups sharing within the lab group or with external collaborators. It's no cost to researchers. We have a campus site license for this. We also have recently gotten approval from the campus to use it with restricted data. Chris.
Yeah, so other options as far as storage include all three of our cloud providers. A couple things I'm going to highlight. They have tons and tons of different offerings. So we've been talking about file storage. We've been talking about block storage. There's also object stores, backup, archival. I didn't even come close to throwing all of the icons on there because it would just be a mess of icons. A few things to highlight. One of the gotchas of cloud is usually that it's the Hotel California of data. You can put it in, but you have to pay to get out. That is not the case with UW accounts. There is an egress waiver in place for all 3 clouds. So we have the vast majority of the cost to move data out of cloud waived. In fact, most Internet 2 universities have never had to pay to move data back out of the cloud. The other thing that's important to note is because it's a UW level contract, the more we, the UW, use any given vendor, Amazon, Microsoft, or Google, we get increasingly discounted storage pricing based on the whole university's use, not just an individual account holder. So we are pretty confident that when it comes to these cloud offerings, storage pricing is, affordable right now and trending down. That said, Research Drive is fully subsidized and has no cost to the researcher for the first 5 terabytes. Cloud's never going to beat free, but at least the pricing is a lot more stable than what you would typically read about with cloud vendors in industry.
All right, thanks, Chris. So I think cloud platforms are a great example of where the data storage and analysis will come together and visualization and where a lot of the research activities and those things come. And a lot of this these kind of research activities are happening on laptops or in servers and in departments or computer labs, and so it can cover a lot of different ground and spaces, and a lot of the parts about having your data and analysis being able to work together and come in. So we're going to look in, there's some cloud platforms or things like that, but then there's also some data platform and analysis tools that are available for campus. So we'll cover some of this space next. Would you advance, please, Jen?
Mm-hmm. Erwin, I think this is you. Oh, you might be muted.
I was totally muted. Hi, I get to talk about this part. One of the programs that we're piloting is RStudio Workbench. Probably a lot of people are familiar with RStudio, and RStudio Workbench is run on the server. And one of the really neat things about it is that lots of us are familiar with RStudio, and the server version of RStudio is completely transparent. You get all that familiarity. But beyond that, using RStudio, you can enjoy things like using RStudio Workbench to run your Jupyter Notebook scripts. And you're not limited only to R. You can have Python running in it, Julia running in it. You can have SQL queries natively running in your RStudio Workbench. So this is great for our researchers. And very recently, we have been experiencing with beefing up RStudio. So we are collaborating with the Center for High Throughput Computing. We have a Kubernetes cluster that we're testing, and we have access to AWS power behind us. Next slide, please.
All right, so Globus is a new campus offering, and it's a research data management and data transfer platform. So it's pretty neat because it allows interconnectivity between a lot of these different storage systems or computing resources and platforms. So it's a web-based system that then people can connect into and then be able to access different systems. You could use it to transfer data from Research Drive to AWS, or to move data from AWS to a campus computing center, or various flows like that. And then another really neat piece is that it supports federated identity and sharing. So that is a long name for saying you can share with people's institutional credentials. So we can share with collaborators at Iowa using their Iowa credentials, not have to get them a UW-Madison one, or vice versa. We're starting to see a lot of interest in it, particularly for supporting sharing restricted data, like regulated data sets or HIPAA data, where there's data use agreements and contracts in there. This has been a tool that's been approved for those sorts of data exchanges between parties, and we're seeing a lot of interest in that space. All right, thank you.
So we're in our analyze and visualize piece. One of the things I want to call out from cloud compute, because many people are familiar with, hey, Amazon can run your server instead of you having to run your server. But there's a lot of interesting potential use cases for cloud compute that have nothing to do with servers. And this is a architecture diagram from work we did with a particular lab where they had audio transcripts. Those are sitting in a Google Cloud bucket. This was all in Google, but it could be done in any of our 3 clouds. And it's using what are called serverless functions. So in this case, it was a Google Cloud function, but it could be a AWS Lambda or an Azure function to do speech to text transcription. So we're using compute, that's a Python script that runs on a trigger and sends stuff to an AI API and writes it back to a cloud storage bucket and then formats the transcript. All of these steps in this workflow are happening with not a single server that anybody's responsible for keeping patched or updated or secure. Amazon handles everything below that layer. So we were able to build a pretty complex workflow with a very low code environment. The cloud functions can be written in really familiar languages like Python, JavaScript, Java, C#. So I think there are a lot of untapped potential for people who are comfortable with writing some code, don't want to build full on software, don't want to have to run full servers, but have these sort of data workflows where we can pick and choose some computing options from the cloud set of tools to really achieve some interesting goals. And I actually think we skipped the visualization tool slide, Jan. So if you could go back to.
You're right. Thank you.
Thank you. There's also like all things cloud, there's about 23 tools in the toolbox. There are a lot of different visualization tools within these 3 cloud platforms. One of my current favorites, because it's the low price of free, is Google's Data Studio. Any of these tools that you see on the right can be connected up to everything from, a legit database to a whole set of flat files to all kinds of other data sources, but then have differing degrees of complexity in how complex the visualization can be. And I'm going to call out Sam, our undergrad, who has spent a lot of time helping us with visualizing data about our actual cloud usage. That's the graph you see here. And it's dynamic and filterable and constantly updated. Nobody's keeping these stats up to date. You can mouse over things, you can drill into things. All of which was done with Data Studio, which he had not seen or touched until he started hanging out with us. So the learning curve on Data Studio is really, really low. As you kind of go through the list, with great power comes a greater learning curve. So some of these other tools are a lot more powerful, also have a little higher learning curve. But one of the neat things about our cloud contracts is we get this whole suite of tools, and RCI can help advise on the right tool for the job.
Erwin, I think, is this yours?
I'm next again. If you remember the cycle that we have earlier when we started this talk, we talked about publishing. And this is one part of that cycle that we can help you. We have a series of tools that will help you disseminate your research beyond, journals. And you can make it so that you have immediate availability for your research, and you can choose how and to whom you can share this. So you have a lot of control in those. And of all these 3 icons that you see here, I'm most familiar with RStudio Connect and GitLab. I'm going to tell you a little bit about them. Next slide. So this particular tool, RStudio Connect, is you can do quite a few things with them, but I'm going to highlight reports. You can create a report with an Markdown document, and then as simple as push it to RStudio Connect, and you can choose who your audience is. But you're not limited to Markdown. You can also publish your Jupyter notebooks. You can publish your code as API, and you can use Plumber for R or Flask. You can publish your data set using this package called PIN that we highlighted last week. And you can also create interactive web applications with Shiny. But if you prefer to move, you can to a different language, you can use Streamlit for Python and plotted plots. So you have quite a few options here. And it's all at the touch of a button if you decide to go with RStudio Workbench. And next slide.
So this is another one of those situations where the cloud has a bunch of different tools. I'm going to choose to highlight AWS Data Exchange, but you should know that there are many equivalents in the different clouds and many different nuances to it. AWS Data Exchange is a product that allows researchers to publish their data sets, including the metadata that surrounds them, including the hosting, and all of the cloud vendors have different registries of open data sets. They also have the ability to publish in a more secured way. So for example, we have researchers on campus who deal in satellite data, and they are actively talking to AWS about both using AWS to offset the cost of hosting that data. It's called requester pays, where if you want their data, you're going to pay for the transit and you're going to pay for some of the underlying computing costs to get your hands on it, to just offset the cost of making your data available. There's also some new features coming out that allow people to have to pay for valuable data sets. So this has been used on campus for a wide variety of things, everything from let the data be free, I'm perfectly happy to host it and I just want to get it out there and have this data set be reusable, to, hey, I'm gonna help offset some of my infrastructure costs with chargeback. And then all of these tools can be hooked up to the aforementioned visualization tools. So hook it up to Databricks, hook it up to Looker, and do further visualization with these open data sets.
All right, we're nearing the end of the cycle here, and at the project closeout phase, there's definitely a number of considerations. This is a big part where we partner up with the libraries and other parts of campus, for data repositories or getting data out and shared. There's the Minds at UW repository, or a lot of domain specific options in here, and there's also Data Dryad, but that's only one piece of it. There's the computing or other resources that that are in there, and what needs to keep staying on, what's short term, and what's going to be part of the next project or grant in there. So those are some of the considerations. We'll talk through an example next about some archival considerations.
Sure. So archival storage, and I'm using this term loosely. So my friends in the libraries would ask me what I mean by this, and I'm not talking capital P preservation here. I'm just talking data that you need to keep around for a number of years, and you may or may not touch it again. There are a lot of different layers of archival storage available through our cloud vendors. We are talking to some labs about using them because they have exceeded the amount of data that fits in sort of the subsidized storage in Research Drive, and need somewhere inexpensive to put things, and don't want to be running tape systems anymore, and don't want to buy servers that they have to maintain anymore. The cloud is really, really cost competitive when it comes to cold storage. The other thing that I think is really, really neat about some of these tools is they get stitched together with the AI offerings from the cloud team. So AWS has a product called intelligent tiering, where basically it scans your files and says, you haven't touched this one in 30 days. I'm going to move it down to a slightly cooler tier. You haven't touched this one in 90 days. Let's start to move it down to an even colder tier. And your cost goes down as you get moved down into those colder tiers. So it's scanning for what can be moved to a cheaper level of storage proactively. And then because the robots are deciding what level it puts it at, you actually don't pay to bring it back out of archival storage. AWS waives that because you didn't make an intentional decision. And the greatest part about that is the best archival system is the one you will use. And so in this case, if it can be automated, if it can happen either because AI decides it to, or because we can trigger it into somewhere in your workflow and data can just get archived automatically instead of when you have time to clean up your servers. I mean, we've all had that moment of like, I'm going to clean up my file store any minute now. I'm going to get caught up on my email any minute now. Some of the ability to trigger these things automatically, I think, could be really compelling for some labs.
Awesome. Well, thank you, everyone. That was a pretty fast run through of the services that we currently offer and ones that we could definitely help you use if you're interested. And now that sort of leads to the part of our presentation today that's more interactive with you. So we are really interested in hearing from you kind of what your thinking is on any of these questions. Like when you think about how you're doing your research, maybe the data lifecycle sort of prompted you to think and that as using that as a framework. What's going well? What's the hardest part, or what are some of the hard parts? Are there some tools and technologies you would like that are missing from your workflow? Again, are you spending lots of time doing something where it's sort of, you could imagine there might be a technology or an app that could sort of do some of it for you? What are some ways that our group, which it's a small group, but we're growing and definitely want to expand and offer more services as the need arises. Any advice you could give us on how we could help? And I think I didn't see anything posted in chat. I don't know if another member of the team saw something that we could kind of address right away, but please feel free to think about these questions, unmute and talk to us, or if you're more comfortable putting something in chat, please do that.
Jim has a
Yes.
hand up. Go ahead, Jim.
I'm so polite. I raised my hand.
You are.
And maybe the hand will go away on its own. I don't remember. We'll see. So Sarah knows this. I've interacted with Sarah quite a bit over the last few years. So I work in the Department of Geography, specifically in a unit called the State Cartographer's Office. So we're the map people. And I work very closely with another sister unit called the Robinson Map Library, also in geography. And one of the challenges that we face consistently and constantly is storage, data storage. So to give you a sense of scale, without getting deep into the details, I mean, right now we're managing probably 80 to 90 terabytes of mostly raster data, aerial photography, scan maps, things of that sort. And the life cycle is not at all sustainable. And what I mean by that is, right now, through our partners in space science engineering, they've got a bunch of disks kind of spinning where all this stuff sits. It's kind of backed up, it's kind of not. Those disks are going out of warranty, probably have been out of warranty, so it's a little bit scary as far as what the future holds, especially when it comes to cost and trying to do this, because you all know, working for a university, everything is so intimately tied to grant cycles, right? So we've got this one need for lots of storage. The limitation of, well, the funding cycles are irregular. How do we possibly keep this stuff going? Chris is nodding her head because she hears this every day. So, I guess I'm just more painting a picture of this as an example. We don't really know what to do moving forward. I'm aware of what you guys do. I'm aware of the different cloud services out there, for example. I always, frankly, get scared away when I start doing the Amazon price calculators, 80 terabytes times X equals Y dollars. And it's like, okay, there's no way that's ever going to happen. But that's, not based on not a lot of education. So I guess, me understanding now or later how to engage with you folks and how to, help us figure out, what the limitations might be, the costs, the IT folks that I work with, locally. Let's just be honest, all of us kind of being IT professionals, and especially folks that, maintain hardware, they like more hardware. So cloud stuff, you know what I'm saying? Anyway, I'll stop there. That's kind of the picture that I'm trying to paint and trying to deal with.
Yeah, I'm going to look at Mike here to weigh in just a second. I think the biggest piece of advice I'd offer is we'd love to have a more detailed conversation about what your pain points are. And the fun thing about doing cloud at the university as opposed to doing it in private industry is Mike and I both work for Bucky. It doesn't matter to us if the data goes in Research Drive, the data goes in AWS, the data goes in Google, the data stays at Space Science, and my husband continues to maintain those disks. All of those are perfectly viable options, and I don't get any bonuses for talking you into AWS. So we have, with a number of labs, gone through some pretty detailed use case analyses and talked about the data lifecycle and when do you need it and what do you need to do with it so that we can help advise what the right place is. I think broad strokes, and I think Mike would agree with this, though he should pipe up if he doesn't. If your computer's in the cloud, that's one of the places that it really makes sense to move the data to the cloud. If your computer's all on-prem, it probably doesn't make sense unless there's a compelling price point for something like archival storage. If you don't want to be dealing with tapes anymore. On the other hand, if you just bought a tape array, you just bought a tape array, it's paid for. Mike, what would you disagree with or add?
No, that's all great. I'd say that there's not one right answer, and a big piece to emphasize is this is a portfolio approach. Like, we're looking to have options, we're looking to have building blocks, we're looking to have flexibility if it's contracts or data center space or having storage ready to go. The right fit really depends on the situation and on a number of those aspects. Another piece I'd really emphasize is that we really try to work collaboratively with campus units and groups on how to plan and do infrastructure stuff, these kind of pieces, because some of these things have 5 or 10 year life cycles. Some things are you're looking for something for a month. So as Chris said, where we can have conversations or talk, understand roadmaps, things like that, that's really helpful for planning. At a minimum, the biggest value add compared to 5 or 10 years ago is, I think, making sure that the hardware is at least in a decent space, it's protected, you're not at risk at that kind of stuff. There's too much risk at that. You don't want some sort of physical single point of failure, that kind of thing. I think campus has made really good strides on those fronts. If you're already working with a research center, have stuff hosted in there, that's a great example of that. So if it's going to be buy hardware, let's make sure it's at least in a good spot. And campus is looking to have more research data center space and then have more shared services or other things available. And realistically, it's going to be driven by the budget and the needs, and you can plan for growth and changes, and those are the sort of things. So there's not one like pick this thing, this is the right thing to do, but it's based on that. Does that resonate? And
Sorry, mute button. Yeah, no, it does. I guess the question I'd have is, where does that begin, and who does that begin with? Who do I talk to, in other words?
Well, you came to the right place. I mean, we can definitely, we want to, these are great themes, and we're happy to continue addressing, them in here, but very much would, we love doing consults and follow up and stuff like that. So we can, get more specific, or this is a, great considerations too. That's, on the really big side of it. Don't want to just say like, that's the only kind of data problem or anything. Like, there's a lot of, a lot of different sides of it, but that's a really great one to tackle, just because there's a lot to that.
Okay, so I just saw in the chat, so reach out to Chris and you, Michael, directly, it sounds like.
Yeah, and the other thing I frequently do is we have a rep for each of our cloud vendors. If you have an initial conversation with Michael and we think that you at least want to explore cloud for some element of that data lifecycle, then we talk to them and say, we're talking about this many terabytes, this many petabytes over this many years, and we can have a conversation about Does that get the UW to a level that we start to talk about private pricing? Do you, because of your funding cycle, need to talk about a pre-purchase while you still have the grant? Because a monthly bill doesn't work in higher ed lots of times. That's one of the places where the vendors are starting to realize they need to work with us in a different way. So we can at least approach our contacts who work with us, work with higher ed every day, and know these pain points and say, help us solve for this, or can you help us solve for this? Because if you go in the front door and talk to whoever you get at Amazon, you're going to get the typical Amazon pitch of total cost of ownership. And that doesn't resonate here.
Right. My electricity's already paid for, sorry.
Yes. Yeah, exactly. And that came out of your researcher's grant, and they will rightfully say, I'm not going to pay for that twice. I don't care if Amazon's electricity is cheaper. I already paid for it. But if there's a place where a hybrid setup makes sense, we've also done that. If it doesn't have to be all cloud or all on-prem, we can do the networking into the clouds to be able to move data back and forth. The other thing I'd say, just generic cloud advice, is do a small little proof of concept. The best way to know what it's going to cost you in the cloud is not those calculators. I use those calculators every day and they scare me, and I know them well. The best way to get an estimate of cloud cost is to take some small percentage, put it out there, and see what the real charges look like in your real world use case scenario of how often do you touch it? How much computer are you running against it? We can give you tools to measure and monitor that, and then decide, this is a terrible idea or this is a great idea, but you haven't made a capital investment. So if in a week you decide AWS is not for me, we shut it down, you never get charged another penny.
Yeah, thank you. No, I'll definitely reach out to you too. That's good advice as a starting place. So thanks.
I appreciate it.
Yeah, thanks for
waiting
bringing
on
that
the
up,
questions.
Jim. Thanks for bringing that up, Jim. And it makes me wonder, is that sort of resonating with anyone else out in the audience? Is data's a pain point for others? Oops.
Well, people think about that. I think I forgot to mention when I was talking about our Studio Workbench and our Studio Connect, I said those were pilots. And if you want to be part of the pilots, we have licenses that will let you dip your toes in it. You can use either one of those services, and Sam is going to post on the chat how you can request one of those licenses. So if you're interested, send us an email or fill out the form, actually.
Cool, thank you, Erwin. So what other what are other folks thinking about, like, tools you wish we had? Like, think big. Is there some amazing thing you wish campus offered that we could get started thinking about?
Well, I clearly, in my case, I'm not going to wear out my welcome here, I hope. But I mean, I wish there was, box times 100, that I could just dip our 100 terabytes of data into, but that's, wishful thinking. But if we're really dreaming big, that would be the kind of stuff that I think would benefit, my little world for sure.
So Jim, I'm going to ask the follow-up question. Box times 100, is that the freeness? Is that the onlineness? Is that the ease of use? What about box would make you want to times 100 it?
Yeah, so not when I say this jokingly, right? But I mean, not box as a tool per se, but big storage buckets that cost us little to nothing, reasonably or not, to put stuff in, so we don't have to worry about that. So that we don't have to think about, is it backed up? Is it not backed up? Again, as I say these, I realize they're half-baked thoughts, but if we are dreaming big, these are the sorts of things that, benefit the world that I live in. So the freeness, the not having to think about, is it backed up if something blows up, God forbid, the tools and how the hows we can always figure out ways to make the technology work. I don't like so much care about that side of things. It's just let us focus on getting the data out to the folks using the mechanisms that we have currently. We're pretty good about providing the access. It's the behind the scenes is where I'm going to say we struggle a little bit. We know our community and those that they want to get to. We provide the support, yada, yada. It's the tools that are deeper down in the stack, I guess you might say. So this maybe answers your question, maybe not, but that would be my big crazy dream to Jan's question.
Well, and I appreciate you diving deeper because, part of the reason in my world there's 75 different storage options is, the follow-up question is storage for what you mean by storage and what I mean by storage. If you're touching those files 423 times a day, and I just want to make sure that I don't lose them, those are different, to do that well is sometimes a different tool.
Yeah.
On the other hand, that's not the greatest research experience of like, okay, you've given me the most intimidating thing about AWS is there are 250 services in there and they're all named after Greek gods. So how do I know which one I'm supposed to use? Part of me is like, let's bring all the specialized tools to the table. On the other hand, one of the things we hear from researchers, and I would love feedback from the audience on if this is true, is, oh, for Pete's sake, I just tell me where to put my data. I don't want to make these choices. I don't want to have a detailed consult. So I would love to know from the audience if like, hey, I don't care if it's the perfect tool. I just want one. That's what the students told us about an LMS. We just want one. We don't care which one. I'd love more nuanced feedback on when it comes to tools and tooling. What's helpful and what's not?
When we saw that, back in the day before things changed, when, Box was unlimited, we thought, okay, someone's going to regret saying that because here we go, but we recognize there's limits to that. So yeah, kind of like you said, it's like, I don't really care if it's Box, Dropbox, whatever. It's just, a tool that's big and cheap is what matters to me. But I'll stop and let others chime in.
I've got one quick question for you in terms of big. When we did Research Drive, we did 5 terabytes, and that wasn't going to cover everything, but was thought that there's, that maybe in the 80% or covers a lot of sort of needs. And just curious, you said you're, in the 80 terabytes total or, accumulated now. Just curious if you have any kind of like year-to-year growth or projection, or how much is, what's the line of growth look like basically?
It's a simple question with a complicated answer. Here's a for instance. Sure. So statewide aerial photography, the stuff you see in Google Maps, digital aerial imagery, every 5 years, typically that could be 40 terabytes-ish. I'm making very broad generalizations. Resolutions get smaller and smaller. When a county collects elevation data across their jurisdiction, that could be a couple terabytes. That maybe happens every 8 to 10 years. And we're becoming a de facto storage place for all this, by the way, which is why I'm going with this. So you do the math. I mean, is it 10 to 15 terabytes a year? Yeah, somewhere around there, I guess. So percentage wise, 10 to 15% potentially, if we could do everything we want to do.
That's really helpful. And the other part that really stands out to me, and we're seeing a lot more common, is that there's real patterns of growth. There's either seasonality or it's around projects or different phases. And so it's not just one linear trend, when things are growing or how you interact with it and things like that. And that, that's just, it's interesting on, making out long-term projections or just understanding those kind of things. So that's, if it's with us or, looking at any of those kind of things, I think that's definitely very much a trend of trying to identify some of those patterns of use or things like that, and have some of those contexts that can help, give more, get the better confidence interval on what, what this might look like for a trend or projection.
And to be fair, I don't probably represent your typical researcher. What we do is more provide service to folks in our community. So we're quite unique in this regard. We have statutory responsibilities, but yet we sit within the university to do certain things. So, I'm not a medical researcher cranking out, I'm just making stuff up here, genome data about something that, we're very different in this regard, right?
But yes and no. Same genome researcher needs to keep their data for somebody who's going to try and replicate their findings, for, hey, I think I've changed my process and I need to rerun this all from scratch. So yeah, your use case is different. On the other hand, with my IT hat on, I hear a lot of commonalities.
So I'm wondering about, like, this is a data science event. So I'm just sort of wondering, what about some of the data science like platforms and tools? Are there some needs out there? Are there, like, that doesn't sound like something where we'd standardize on just one tool necessarily, but maybe we would want to. Curious about if there are, like, any thoughts on, wouldn't it be nice if the university provided a platform or a tool for my data science work? Some universities provide like a Jupyter Hub service, or we do have GitLab available for research use now on campus. So I don't know if everyone's aware of that, but that's something you can definitely use. But just wondering if there are like some visualization analysis kind of tools that are maybe widely used, expensive, that might be nice to have the university sort of take a hand in providing.
Just to make sure I understand your question, Jen, you're asking if as researchers we have a tool that we would like to have access to that is not widely available. Is that what you're saying?
Yeah, so I think we sort of framed it as like, what are some tools you wish you had for your research? And, is there a way the university could sort of help provide tools? So not looking for one particular thing to be named, but just sort of, wondering how self-sufficient folks are with that, how much like the university could help in that regard. Or any other area, any other feedback that someone would want to share, or observations they would want to share.
Not an observation, but I mean, I really like our Studio Connect for publishing, I guess, is a random observation. But Chris, I was thinking about what you said about both paying ahead and requester pay. And I could see that for like open source projects, maybe like we want to pay for 10 years, but we want to do requester pay when people are pulling down the data so we can expand that past 10 years and make sure we have longevity. Are there setups like that? And how do people decide what they'll have their requester pay?
Yeah, so right now, what requester pays, which is a specific service from AWS, so I'm going to answer that and then I'm going to broaden out the scope. What requester pays does is offset, say, Jim puts 53 terabytes of data out there and somebody decides they want all the pictures from the beginning of time of this particular area and pulls them across the wire into their AWS account. That would potentially give his AWS account some significant charges if it goes over our egress waiver, or if they're pulling a bunch of data, or it requires a lot of read and writes. So what that protects Jim from is, if I want his data, have to have my own AWS account with my own billing, and those charges, instead of going to his AWS account as the provider, go to mine. What we're talking to people about, and we have a researcher in space science who's helping push this forward, is a little bit above and beyond that of, I don't want to just protect myself from it costing me money to do the right thing and share the data. I actually know that my data has inherent value and I want to charge for it, which they haven't done yet, but AWS is actually moving forward a request from the UW to look at that, because they have a lot of the infrastructure in place with requester pays. that you could just as easily say, for this 53 terabytes, I want to charge you $1,000. And it's going to go against whatever billing source you have set up according to your AWS account. So that there's a very real possibility that the feedback from our researchers will go right towards that sort of enhancement. So whether you think the cloud does it yet or not, please come talk to me because they are listening. They love writing about cool stuff that's happening in higher ed in the cloud. So Google in particular is amazing at bending over backwards to help us. Which is kind of a long-winded answer to your question. And I feel like there were multiple parts to your question. So what did I forget?
No, I thought it was good. What I'm hearing is currently the it's the AWS cost that the requester is absorbing, and then
Yeah.
there's the possibility of like having some of that come back to the data provider as well, maybe to cover their own costs for that data, or in theory they could make money from it. But I'm imagining a project where you're really wanting to cover your own costs, because I like open source and open sharing of data.
Well, and I've been part of I'm an ex-software developer. I've been part of lots of projects where people are like, I would love to share my data. I would love to open source my software, but who's got time for that? And I can't afford to pay for the server for the rest of time. Mm-hmm. So even if it just sets someone up to be able to have it be sustainable for them, cool, I'd love to make my images that came down from the satellites at space science available to the universe, but I don't want to maintain this FTP server anymore. Moving some of that off of the responsibility of the lab, so it's not such a big lift to do the right thing for higher ed, I think could be really compelling.
Providing sustainable funding for the things that you still need to do long term, because it's sometimes really hard to get funding to like continue to maintain a project, right? Anything new is a little bit easier to fund than something that where you're saying like, we just want to keep this going. We want to continue to offer this service. So I think that providing an alternate way for those funds to come, maybe it's somebody else writes a new grant that uses that data, and that's how the money's coming back. But having more sustainable funding for this long-term data sharing and providing data resources for people, it's really interesting.
Yeah, and I should have mentioned, I think I glossed over it pretty quickly. There are also offerings where they will say that's a high value data set. We, AWS, will pay to host it. We'll put it in our open data repository. They have data sets out there. Now, in that case, they define high value. And by high value, they usually mean lots of people want it, as opposed to this is an incredibly unique research data set. And for the 10 people in the world who understand it, it's potentially life-changing. They mean it's data that lots and lots of people are going to want to download.
Chris, excuse me, I'm just wondering, what about funders? I mean, this is a good question for our audience. Are funders starting to see the value of archiving data sets that they funded the collection of? Are like the requirements for data management plans driving any kind of increased interest on the part of funders for paying for this, like the archival storage of data beyond a single grant cycle? Just curious if anyone is kind of hearing anything from their funder along these lines.
Everyone's being quiet, so I guess I'll say my part. So, when I referenced 10-15% growth every year without getting, yet again, deep into the details. I mean, a lot of the data that we're schlepping around, it's taxpayer funded. So it's created by the use of, from taxpayers. And, a statewide airphoto flight that's the 40 terabytes, that's maybe, I don't know, $3-4 million of investment. And you know how much money is invested in storing it and distributing it? That's my political battle I have to fight, but that gives you a sense to your question that no, it's like, let's create it. Yeah, we'll figure out the rest of that detail later. I'm serious. I mean, this is the issue.
Yeah.
Cameron, have you seen any push in research data management around funders thinking more long-term about the archiving and storage and use of the data that's being generated?
Yeah, I was just typing in the chat. So, I mean, for certain types of data and for certain sizes. So really right now, all funding agencies are really thinking about is deposit into recognized data repositories. So those are institutional, discipline agnostic, but widely used, or domain repositories. So really we're talking about data that can fit in a repository, right? So they'll allow you to, in your budget, most funders that I know of at this point, and I know for sure NSF and NIH do, they'll allow you to budget for cost and preparation, curation, potentially staff to do some of this work, and then actual, if there is cost for deposit of the data into the repository. However, this is part of your one-time funding. So one of the things that does remain a really huge challenge for a lot of researchers and those with really big data who need to think about these things over the long term. And actually, for any researcher who has to deposit their data somewhere to archive it, to comply with our campus requirements, our statutory requirements, all public records, all of those things, compliance. It's a challenge for everybody. When your data is that big, there's ongoing costs for it, and no one is currently paying for those maintenance costs. That continues to be a huge issue for researchers.
Sounds like there's push, so like there's a bit availability for when you're depositing it to a central repository, Cameron, which is probably smaller amounts of data. I'm wondering if there'll be push for long terms of this when those repositories that are not funded federally will need to have long-term support for continuing to host those as well.
Yeah, that's a really interesting question. So we're seeing data repositories struggling with this. So Dryad, which we're actually a member of, moved to a membership model to account for sustainability of growth over time and being able to steward these resources, because stewardship requires not only infrastructure that's constantly changing and updating, but also people to take care of these things. We're seeing NIH just announced a new initiative where they're partnering with 6 different, some of them are disciplinary, most of them are disciplinary agnostic repositories. I don't know how much of that partnership includes any sort of funding or support, but we are seeing repositories have to grapple with the fact of like, we're doing these things, but how are we going to make this sustainable long term? Because right now agencies aren't really helping us do that.
Great. Now's the time we could go to breakout rooms, right? I think we're just a little past the time point for that. But I really enjoyed the sort of bigger group discussion and got a lot of great ideas.